All right, so looking at solving systems of equations, I thought it was kind of humorous. The textbook did this all in one lesson. Everything that you learned about systems of equations, just about in Algebra 1, all in one lesson. And so I obviously have broken it into a couple of days because we are not going to finish all that we learned in Algebra 1 in one day about systems of equations, mainly because what I've learned with systems of equations is the vocabulary maybe not was used fluently enough. And so it's when you start doing the problems, you start recalling what you're doing. And so it's not a hard topic. It just takes a little time to refresh everybody. And so we'll look at graphing, we'll look at substitution, we'll look at elimination, and we'll look at special cases. We make it to the start of substitution today. I don't know what's making me take so long, but it is taking a little bit of time. So we'll start with just defining what systems of equations are. What do you recall systems of equations to be? What you think? Some more than one, right? A set of equations, two or more. It's got to be two, at least. And they're going to have the same variables. Also, important part about systems of equations is their solution is their point of intersection, their point or points of intersection. So we'll look first at the graphing. So when we're looking at graphing, the first thing that we need to do, let me say this, this whole chapter, solving systems or systems of equations, is basically a whole bunch of different methods to get to the same point. Is everybody with me? So like on quizzes and homework and stuff, it may say solve by graphing, solve by substitution, solve by elimination. But when you get to a multiple choice test, does it matter which one you use? No. The result is what makes you comfortable. What do you know what to use when it's easiest, or what you use that makes you more comfortable when you're working it, and it doesn't matter. Okay. All right. So solving by graphing, we have to start by getting our equations into slope-intercept form. So we can get it into y equals mx plus b. So I'm going to solve for y. So I'm going to get y by itself. Subtract 2x from both sides. And then I'm going to divide by the negative 1. So when I do that, I get y equal to 2x plus 1. So that's one equation.
One question.
Yes?
Is this same if you like do 2x, you like put it in the other side and you do -1 minus 2x. Is it the same?
Try me again.
Like, on the, if you see the black equation,
Mhm.
2x, you put it next to the -1, isn't that the same?
Yeah, that's what I did, but you have to change the sign if you're moving it across the equal sign.
Yeah, but it's the same.
Right, that's what I did. Okay, and then here I'm going to subtract 5x from both sides. So that gives me the 2y equal to negative 5x minus 16. And I'm going to divide everything by 2. So I get y equal to negative 5 halves x minus 8. So now I'm going to sketch a graph so that we can put this on the graph. And I'm going to start by graphing the y equals 2x plus 1. So I'm going to start at plus 1 being my y-intercept. So I'm going to go up to positive 1 and put that point. And I'm going to use my slope of 2 over 1 to put other points on the line. I can go down 2 into the left one, or I can go up 2 into the right one. Once you've gone across your graph, may I recommend a nice long line here. So, because you don't know where the other one's going. Oops. You don't know where the other one's going, so you want to make sure that you capture everything it might run into. All right, this one's going to start at negative 8 on the y-intercept. And if I go down 5 and to the right 2, that's taking me away from the line that I want to intersect, right? So I'm going to take it up 5 and to the left 2. Did I put a point wrong? Oh, I didn't go up far enough. And there it is. So I can go ahead and draw that line. And I have my point of intersection happening right here. So I want to write that point as my solution. So the x is 2, negative 2, and the y is down 1, 2, 3, negative 3. So negative 2, negative 3 is my solution. Questions? Give me a second to get that. Good? All right, so let's try this one. Four x plus 3y equals negative 24, and 8x minus 2y equals negative 16. See what you can do with that one.